Welcome to a video on chapter 5 of statistics on data production. Also involves experimental design. So it's one of the critical parts of AP statistics because if you don't correctly get your data, then you can do all the math statistics in the world. But if you have bad input data, you're going to get bad output data, even though you've done the mathematical processes correct. I want to start off going back to our summer reading by the Ghost Map, because there were a few quotes in it that I thought really applied to this chapter. The first here is, there was a correlation between water supply and cholera. That much snow had convincingly proved, but he had not yet established a cause. So he needed to somehow prove causation, which will be difficult in the environment he was working. Then another man involved in the keeping of the statistics for London at the time was Farr. And Farr was a man of science and shared Snow's belief in the power of statistics to shed light on medical riddles. But he also shared many assumptions with the miasma camp and used the number crunching of the weekly records to reinforce those beliefs. So this just brings to light that you've got to be careful of your own biases when you're collecting data and do things in a correct scientific method and let the numbers tell you what's happening, not try to prove what's happening with your numbers. So you got to let the data and scientific method work for you and not try to manipulate them to meet what your preconceived notions are. And also one other quote about correlation versus causation was when Farr discusses proving Snow's hypothesis. To measure the effects of good or bad water supply, it is requisite to find two classes of inhabitants living at the same level, moving in equal space, enjoying an equal share of the means of subsistence, engaged in the same pursuits, but differing in this respect, that one drinks water from Battersea, the other from Kew. So William Farr there is describing what's you're going to learn is called blocking for an experiment. Or if we're doing sampling, it's going to be called stratification. All right, and the last quote before we get into the meat of this chapter is from one of the newspapers of the time. The experimentum crucius would be that the water conveyed to a distant locality where cholera had been hitherto unknown produced the disease in all who used it, while those who did not use it escaped. So that would be the best experiment. Give some people one water, give some people the other randomly, and see who develops cholera and who does not. But that leads to the big ethics problem where you can't always do an experiment because ethically it would result in either loss of life or medical complications. So sometimes we can't do experiments and we just have to use a preponderance of data. For example, with the smoking causing lung cancer, you can't tell people, hey, you go smoke 10 packs a day and we'll see what happens. That's not ethically valid. And in the book, Ghost Map, luckily, this experiment was unwittingly run by somebody who carried water to another locale because they liked the water at Broad Street. All right, so let's now get into all of these things in a theoretical way instead of in the book. So 5.1 is designing samples. We have two kinds of ways we can do studies. One's an observational study. We observe individuals and measure variables of interest, but do not attempt to influence responses. What that means is you're just gathering data, you're an observer, thus the name. You're not applying some kind of treatment to affect change in the outcome. Whereas an experiment applies a treatment, which is making a change that you're trying to measure what that treatment, how that affects the outcome of one variable that you're measuring. When we go to observational studies, there's two kinds. There's the retrospective and the prospective. So retrospective looks back at previous data to do the study. So that's kind of what Snow was doing in GhostMap. He was using the tolls in the newspaper and the accounting of deaths and all the different factors, and then, or going backwards in time and trying to figure out who went where. A prospective study watches for outcomes of such as the disease of cholera during the study period and relates this to other factors such as suspected risk or protection factors. It usually involves taking cohorts and watching them over a long period of time. So that's taking a longer view at it and looking at the outcomes of different groups of usually people. All right. So observational studies, pros are they're usually easy, less expensive. You usually don't run into ethical issues with observational studies. The problem with them is you can't prove causation. We can give high certainty that there is some link between two variables, but we can't specifically prove causation without an experiment. Whereas with an experiment, that's when we can prove causation, because we're going to try to control for factors and then do one change called the treatment and see how that produces an outcome on the subjects, if they're people, or the treatment units, whatever we're applying the change to. So the pro is we can prove causation, and if done right, you can get reliable, repetitive results. The con is experiments can be expensive, take time because of all the different government or ethical constraints you have to meet. For example, with the COVID vaccine, there's different stages of the trial to prove whether you have any side effects, if it's safe, and then once that's proven, then you go and see does it actually protect against the COVID virus. All right, so we're going to go to sampling for right now, just a little terminology. So we've talked about this earlier in the year. A population is what you're interested in expanding your results to. So the whole group. For example, if we're talking about the election for president, our whole population is probably the United States. If we're talking about the sample, that's the small subgroup we're going to pull, because we don't want to pull the whole United States. So we're going to just sample a few of them, and they need to be representative of the population. So that's the trick of making sure you get a representative sample of your population. Now, the population doesn't have to be as big as the whole country. It can be, what if we're just interested in Massachusetts or just interested in our high school? You can have populations be different large groups, and then your sample just has to be representative of whatever your larger population looks like. Instead of sampling, you can do a census, which is if we're talking about people, you talk to everybody in the population. That's expensive and time consuming. That's why we do statistics and sampling. But in the United States, every 10 years, there is a census that goes on to make sure we count everybody in the United States. Sampling, the terminology we're going to do for sampling is only used for observational studies because we want to get a representative grouping of the population. Experiments don't use sampling. They use volunteers if we're talking about people. So you want to make sure you don't use sampling words when you're talking about experiments. All right, so let's talk about some bad methods of sampling. There's voluntary, and that's when people volunteer or choose themselves. So for example, if it's a TV poll and it's either Fox News or MSNBC, the two different spectrum there. If they do a phone-in poll, then they're only going to be getting people who watch that channel, and therefore their results are going to be skewed towards that demographic, not towards the whole US. Convenience sampling is when you just basically do what's easiest. I talk to the first 10 people who walk through the door at the mall. So that's not going to be representative. There could be a lot of different reasons why those 10 people come at that time of day. Let's say it's like, morning of a weekday. Those 10 people might all be stay-at-home parents, and therefore they can go to the mall at 10 a.m. on a weekday. So there's a lot of issues with convenience sampling because there's a plethora of different variables that could be masking what you're truly trying to measure. And what bias means is these all cause bias, and that means that your method can systematically favor a certain result. So, for example, the TV example with MSNBC versus Fox. MSNBC poll could systematically favor Democrats, whereas the Fox News polls could systematically favor the Republicans. Right. So what do you want to do? The most common one is simple random sample. We'll abbreviate it as SRS. This is where everybody in the population has an equal chance of being chosen for the sample. And we'll do it a lot of times with our calculators with a random number generator. All right, so simple random sample, that's good method number one. Then we have stratified random sample, and that's where we're going to divide our population into groups for some reason. And then we're going to randomly select within those groups. So let's say we want to get opinions on the election from men and women because we think they have different views. We would stratify them by gender, and then we would randomly sample within each group of males and females. Then there's cluster sampling, which is you divide the population into groups, and then randomly sample the groups. So the best example I can think of for this is, let's say we wanted high school students' views on remote learning, but we didn't want to sample all the high school students in Massachusetts. So we cluster the groups by high school, and then we randomly sample 5 of the high schools and then interview all the students in all of those 5 high schools. And then there's multi-stage, which is you do more of these. So like you could stratify and then cluster. It's just basically doing more than one sampling method. All right. So strata, just to reiterate, is dividing into groups and then randomly selecting within the group. Cluster is dividing into groups and then randomly selecting the groups and sampling the whole cluster, so the whole high school, for example. So stratified samples, you want your strata to be homogeneous. So they want to have something in common. That's why you stratified them. The most common one is gender. So they all have the same gender, or in school by grades. You might stratify people by grades. So that each strata is homogeneous by grade. Cluster, you want to have a similar variation as the population has. So each cluster should be heterogeneous, and then you're sampling within that, then each cluster will be representative of the population. So I have this visual here. I pretend these dots are chocolate chips, and you want to sample and figure out the average size of the chocolate chips in your chocolate chip cookie. Uh, and this, I think, is a good visual of what each sampling method means. So simple random sample, you just got the whole cookie there, you just randomly select different chocolate chips. Stratify, you take out all the big chocolate chips, medium chocolate chips, and small chocolate chips, and then you randomly sample, in this case, 2 in each strata. The cluster, you just like took, I don't know, portions of each of the cookie, let's say, and made them into sections, and then you randomly sampled 3 sections of the cookie and then measured all the chocolate chips in each section. The 2-stage, that's where they did the cluster and then they did a random sample within the cluster. Now there's one last one that we didn't really talk about previous, and that's systematic random sampling, which is you start, let's say, at the 3rd chocolate chip if these were in rows, and then you sample every, I don't know, let's say 7th chip. You sample. The problem is systematic sampling can also put in a systematic error into your data. So like if it's manufacturing and you're measuring every 10th item coming off the assembly line, what if there was an error that occurred only every, 7 or every 20 cycles and you systematically miss it? So systematic isn't used that often. All right, and now we come to things to be careful of with sampling, and the first is undercoverage. That occurs when a group in the population is left out of the possibility of being chosen. And then we have non-response, which occurs when somebody is chosen but chooses not to participate. So the classic example for this is undercoverage is if you are calling, doing a phone survey, but you only have the phone numbers of people who have landlines. Then everybody who doesn't have a landline is not going to have a chance to be chosen. And that could skew your data because people with landlines are probably older than the people who don't have landlines who are younger. So it's people who cannot get chosen for the survey because of some reason. Non-response is you're doing that same survey and you call somebody and they either hang up or just say, no, I don't want to participate. So that is the difference between undercoverage and non-response. And then one more cause of bias can be how the survey is done. So you could have response bias, and that is based on the behavior of the interviewer or who the interviewer is. It could change how people respond. So they could say one thing when in actuality another is true. For example, if I asked you guys, did you ever cheat on a test? If you did, you are less likely to be honest about it to me because I'm the teacher than you might be if a peer asked you. So response bias is a case like that. Or let's say you were being surveyed about your view on tattoos and the person asking you had a lot of tattoos. You're less likely to say, hey, I hate tattoos to a person who has tattoos because you don't want to make them feel bad. Wording of a question can also influence answers. There was an experiment done where they did 2 different surveys. One used the term Obamacare and one used the term Affordable Care Act. And if you don't know, Affordable Care Act is the formal name of Obamacare. And they got very different results depending on which word they used. And lastly, you can improve results with larger samples. So small samples one variation can change your outcome a lot. However, I do want to point out a larger sample will not change underlying issues you have. So if you have forms of bias in your sampling or in your wording, then larger sample is not going to fix that. Nothing will fix that if you just have bias. So, but larger samples do give you more confident results if possible and everything is run correctly. All right, that's the end of this video. Thank you, and I will see you in the next video.